Okay, so this is the solution key to quiz 3. There was only one version of that. And the first one is asking you if two events are independent or not. And so we want to see if one thing occurring could affect the probability of another. So the first is you frequent casinos, you have lost money gambling. Well, that's definitely not independent, right? You're more likely to have lost money gambling if you frequent casinos, right? You are a male, you are a smoker. Those two things are independent. We don't think that being a male increases your probability of being a smoker per se, okay? I mean, it might be true, but there's no reason to think that gender affects whether or not you smoke, okay? The light bulb in your kitchen burns out. The light bulb in your friend's kitchen burns out. Well, these should really be independent events, right? What happens to the light bulb in your kitchen shouldn't affect what happens to the light bulb in anyone else's kitchen, right? So these are independent also. Okay, second problem is talking about 3 bulbs. Each one has a 20% probability of burning out this year. And we want to know what is the probability that all 3 bulbs will burn out this year. So these 3 events, again, are independent, just like these 2 bulbs burning out were independent. So when we have 3 events, their probabilities multiply. So the probability that bulb 1 burns out, and bulb 2 burns out, and bulb 3 burns out is the probability of each of them burning out, multiplied together. So the answer should be 0.008 or 0.8%. Notice we're not adding, okay? This is important to understand. When you have independent events, the probability of all of them happening is the product of their probabilities, not their sum. Okay, it's important to understand. Okay, it says here, a child is presented with a bowl of 8 different pieces of candy, 6 different pieces of gum. She can choose 4 of each. How many choices does she have? Okay, let's look at the candy first. The candy and the gum are independent, right? How she's choosing them. So we want to know how many ways can she choose 4 pieces of candy from the 8 pieces. Well, that's a combination, right? We're choosing 4 from 8, and order doesn't matter. Okay, and we're choosing without replacement. That's important. So this is 8 choose 4. And how many ways can she choose 4 pieces of gum from 6? Again, we're choosing 4 from 6 without replacement, and order doesn't matter. It's another combination. What messed people up who missed this problem was they added these. Okay? Then these are independent. So for each choice of 4 candies, she has 15 choices of gum. You can make a tree diagram, okay, where you could have 70 branches, and each of those branches would have 15 branches. The 70 branches would be the 70 choices, the 70 ways she could choose 4 pieces of candy from the 8. And for each choice of 4 candies from those 8, she would have the same number of ways of choosing 4 pieces of gum from 6. That's why we're multiplying. This is a tree-like structure. And so you multiply 70 times 16 and you get 1,050. That's your answer. Okay, so here we're talking about choosing 5 students from a class of 10 boys and 12 girls for a basketball team. We want to know how many teams are possible. So we're choosing from all 22 individuals. So it's 5 choose 22. It's a combination because we're choosing 5 from 22 where order is not important, and we're choosing without replacement. When you put this into your calculator, that answer is 26,334. Okay, now we're restricting ourselves to the 10 boys. Notice this is exactly like the candy problem. The boys are like the candy, the girls are like the gum. We're choosing 3 from 10, okay? Again, it's a combination for the same reasons. Order's not important. We're choosing with replacement. 10 choose 3 is 120. Put that in your calculator. Now we want to choose 2 girls, 2 players from the 12 girls. And it's exactly the same as B, right? We're choosing 2 from 12. Order's not important. Without replacement, it's a combination. Put this into your calculator, you get 66. Now, we want to figure out the probability that the team will consist of 2 girls and 3 boys. So this is, remember the theoretical probability formula. It's the number of favorable outcomes divided by the total number of outcomes. So the total number of ways we can choose 5 people from 22 is what we got in Part A. The number of ways we can choose 2 girls and 3 boys for the team is the number of ways we could choose 3 girls from 10 and the number of ways we could choose 2 boys from 12 multiplied. This problem, the numerator, is exactly the same as the candy gum problem. I want to know how many ways can I choose 2 from the 12 boys. How many ways can I choose 3 from the 10 boys? And how many ways can I choose 2 from the 12 girls? And these things multiply because they're independent. For every choice of 3 boys, we have 66 different ways we could choose the girls. So these numbers have to multiply. So this gives me the number of favorable outcomes. So it's 7,920 divided by 26,334, which when you put this as a probability, it's 0.3008, and expressed as a percentage, it's 30.08. Okay, these are good problems to practice for the exam.